Greetings, Chem 1 students. This is Mr. Braun, and we're going to start a new unit, and this unit is titled Chemical Quantities. So, today, what do we expect to learn? What are our objectives? First of all, we should be able to state the significance of an atomic mass unit. And the abbreviation of the atomic mass unit we'll talk about here in a little bit is an AMU. We identify the mole as the amount of a substance and understand that the mole is an SI unit. It is part of the metric system. You should be able to recognize that Avogadro's number is the number of particles that are present in 1 mole of a substance. And finally, you should be able to identify Avogadro's number as 6.022 times 10 to the 23rd. So, ladies and gentlemen, let's begin. The relative atomic mass. Okay? Relative atomic mass. We've talked about this a little bit. We've hit on it. It is the mass of an atom measured in grams. Okay? The mass of an oxygen-16 atom is 2.657 times 10 to the negative 23rd grams. So that is a really small number. Well, scientists use standards that are constant and are the same everywhere. That is called the metric system. Now, we here in the United States don't necessarily use those same standards. For instance, we look at our car, we look at the speedometer, and we're going miles per hour. You head up to Canada, they got kilometers. Here in the United States, we go fill our car up with a gallon of gas. Not in Canada. They have a liter of gas. So, we have standards, and here in science, we use those standards, and those standards are called the metric system. In order to set up a relative scale of atomic mass, we have to arbitrarily choose a standard. So we have to base the relative mass on one substance, and all the other masses are expressed how it relates to that particular substance. So when we deal with the atomic relative mass, we base that on carbon-12. So an atomic mass unit, by definition, is exactly 1/12 the mass of a carbon-12 atom. That mass is 1.660540 times 10 to the negative 27th kilogram. So that is how much 1 AMU weighs. It's a very small number. Hydrogen, 1, has an atomic mass unit of 1.00794. Oxygen, 16, atomic mass unit 15.9994. Magnesium, 24, 24.3050 AMUs. Ladies and gentlemen, what do those numbers look like? Yes, you're right, you got it. Those are the numbers on the periodic table. If you have the little one, my little one is a red number above the symbol, okay? That is saying that is the atomic weight. So that's the atomic mass unit for these substances. A mole. What is a mole? A mole is the SI unit for the amount of a substance. 1 mole is the amount of a substance that contains as many particles as there are in exactly 12 grams of a carbon-12 atom. So we have carbon-12. We have 12 protons. We have 12 neutrons. Okay? The atomic mass unit for carbon is 12.011. Once again, 12.011 atomic mass units. So that is equal to 1 mole of a substance. So 1 mole of a carbon-12 atom is exactly 12 grams. Here we go. Look at that cute little guy. That is also a mole. However, this is not the mole that we're talking about. Look at those big fingernails. Better for digging. No eyes. Doesn't need to see. He's underground. Cute little guy. The mole is a similar unit to like we use the dozen. Okay? We use the dozen. We don't go out and say, hey, give me 24 ear of corn. No, 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 no. We say, hey, I'll take 2 dozen here. All right? So that's the way a mole is. Okay? That's the way a mole is. I want 1 mole of carbon, 2 moles of oxygen. We could even break it down. 2.54 moles of iron. That leads us, ladies and gentlemen, to Avogadro's number. Avogadro's number is the number of particles in a mole. It has been experimentally determined in a number of different ways. So, we have this mole. This mole has a specific number of particles in it. All right? So, we can say that the best modern value associated with the number of particles in a mole is 6.0221367 times 10 to the 23rd. So that is the best value given for Avogadro's number. What does this mean? Well, we stated that 1 mole of carbon-12 was 12 grams. That means that if I have 1 mole of carbon, I have 6.0221367 times 10 to the 23rd atoms of carbon. So that is a lot of carbon atoms, ladies and gentlemen. A lot of carbon atoms in 1 mole. Here we go. Here's 12 grams of carbon. That has 6.022 times 10 to the 23rd atoms. I don't know why this is 3. This is just the diagram that I got it from, so ignore that. If you would write this down, write that down as 6.022. Okay? Right here, look at my scale. Here is carbon on my scale. Okay? Look how much I'm reading. 12 grams. Whoa! Didn't we just say that 12 grams is equal to 1 mole? Huh! Right there. That's a mole of carbon. Jeez, I wonder how many particles are in that mole of carbon. How about 6.022 times 10 to the 23rd particles? Specifically, times 10 to the 23rd atoms. So we can call those particles atoms. We'll learn more about those later. We'll just call them right now particles, because particles are kind of the catch-all for all of these. So right there, we're looking at 1 mole of carbon. Look at this guy. Good-looking guy here. A Avogadro. Okay? Here's the man that gave us the number. Okay? So, the number of particles in a mole is known as Avogadro's number, based on this groovy looking guy, Italian scientist, Amedeo Avogadro. So, the man, the myth, the legend, Amedeo Avogadro. You just met me. Check, check. Let me start that again. I just met you, and this is crazy, but here's my number, so mole me, maybe. I don't know. I just thought that was kind of cool. Avogadro's number is the number of particles in exactly 1 mole of a pure substance. So, let's look at my diagram here. I have water, okay? Here's a water molecule, here's an oxygen, here's 2 hydrogens. Now, a water molecule is 18.0 AMU, okay? Well, let's look, how do we get that? How do we get that 18.0 AMU? Well, we're just taking the numbers off the periodic table. Hydrogen has an atomic mass unit of 1.00794. Oxygen has an atomic mass number, or atomic mass unit of 15.9994. Okay? If I add 2 hydrogens, okay, 1.00794, add 2 of those, and to that I add oxygen, I would get the value of 18.01528 atomic mass units. So therefore, ladies and gentlemen, okay, when I calculate the atomic mass units of water, that is how I do it. This number here has been rounded to 3 sig figs, okay? So we take the numbers off the periodic table for 2 hydrogens and 1 oxygen, and it gives me 18.0 AMU. So that would be the atomic mass units for 1 molecule of hydrogen. Well, ladies and gentlemen, we said that if we have 1 mole of a substance, it's Avogadro's number of particles. In this case, we have a molecularly bonded compound. This is covalently bonded. So we call those molecules. So Avogadro's number of particles, in this case, can be referred to as molecules. So in my beaker here, I have water. All right? I have 1 mole of water. How do I know that? Because I've measured it out to be 18 grams. See the similarities here? 1 molecule, 18 AMUs, 1 mole, we've just converted that to 18 grams. So 1 mole of water here sitting in this beaker, 18 grams of it. Geez, wonder how many molecules are in there. I'll bet Avogadro's number. So in this beaker, we have 6.022 times 10 to the 23rd molecules of water. That is 1 mole, ladies and gentlemen. Here we have some different substances. I believe this one is sucrose. 1 mole of sucrose in my measuring dish. 342.3 grams. 1 mole of sodium chloride. 58.4 grams. 1 mole of carbon we already talked about. 1 mole of copper 2 sulfate. Now, ladies and gentlemen, we just went through nomenclature. You should know that this is copper 2 sulfate. Copper 2 sulfate, 1 mole of it right here. 59.6 grams of copper 2 sulfate. How many particles? 6.022 times 10 to the 23rd. How many particles here? 6.022 times 10 to the 23rd. How many particles here? 6.022 times 10 to the 23rd. Ladies and gentlemen, are we getting this? 1 mole of any substance has 6.022 times 10 to the 23rd particles. So 1 mole of any substance has Avogadro's number of particles. Are the masses the same? Well, look at this. Are these masses the same? Absolutely not. So, 1 mole of a substance will have a different mass. The atomic mass units will be different, but the number of particles in a mole is always the same. Avogadro's number of particles. So, ladies and gentlemen, just to wrap things up, the number that we are going to use in here in chemistry when we are talking about Avogadro's number is this baby right here. We're going to take all the back numbers that were behind this off. So when we deal in Mr. Braun's chemistry class with Avogadro's number, we are going to use 6.022 times 10 to the 23rd. We'll get to molar mass tomorrow. Ladies and gentlemen, this has been Mr. Braun discussing the number of moles and Avogadro's number. Have a great day.